Einstein's insight was that when something falls, it no longer feels the pull of gravity. In fact, falling is like floating in empty space. This is the essence of Einstein's happy thought, and what we now call his principle of equivalence. Einstein's point is that when the man in the lift falls, he doesn't just feel weightless, he is weightless. Einstein said the man feels no force pulling on him because there is no force pulling on him. Gravity doesn't act on him, it acts on the space and time around him, what we now call the geometry of space-time. This was a radical redefinition. Einstein says forget the idea of gravity as a force acting mysteriously between two objects. Now we have to think of it as the shape of space-time changing. You see, Newton saw space and time as independent, fixed, and immutable. That three-dimensional space is the stage in which things happen. But time is separate. It ticks by at the same rate everywhere in the universe. According to Newton, an object would travel through space in a straight line unless acted upon by a force like gravity that will cause it to deviate from that path. But Einstein said that space and time aren't fixed and immutable. They're interconnected, meshed together in what is known as space-time. And he said that space-time can be warped, that matter curves space and time around it. So after Einstein, we no longer see gravity as an invisible string pulling objects together. Instead, a body like the Earth warps the structure of space and time around it. And an object in orbit follows a path which is as straight as possible through that space-time. It's a fundamental part of Einstein's vision of reality. Space and time can't be disentangled. You can't talk about space separately from time. So matter warps time as well as space. It's known as gravitational time dilation, and it's possibly the strangest of all of Einstein's discoveries. I've got two identical clocks here. Now, because the clock lower down is closer to the center of the Earth, it feels ever so slightly a stronger gravitational pull than the clock higher up. Einstein's theory says that the lower clock will tick by at a slightly slower rate than the higher clock. Basically, gravity slows time down. It's an extraordinary conception of reality that Einstein describes. Space is being curved and time is being distorted. So why can't we perceive this in our everyday lives? Einstein had a rather nice way of explaining it. Most of us have had the experience as children of trying to work out what our parents do for a living. Well, imagine your father is Albert Einstein. When he was about 12 years old, young Edward Einstein asked his father why he was so famous, what he'd discovered. Well, this put Einstein Sr. on the spot, but he came up with a beautifully simple analogy. Einstein told his son, when a blind beetle crawls over the surface of a curved branch, it doesn't notice that the track it has covered is curved. I was lucky enough to notice what the beetle didn't notice. This is what Einstein meant. The beetle is free to move in any direction on the branch. It can move forwards, backwards, left and right, but it has no concept of a direction up off the branch. It's as though, for the beetle, the universe is missing the third dimension. The beetle may think it's moving in a straight line along the branch, but we can see that the surface it's walking on is itself curving and twisted. Einstein's point was that what we see as the twists and curves of the branch feel to the beetle like forces pushing and pulling it. Okay, so consider this rather strange example. Imagine we have two beetles perched on this pumpkin, and for whatever reason, they want to walk up towards the top. Now, if they start at the equator, pointing due north, as they walk, they will begin by moving parallel to each other. That means their paths should never meet. But as they get closer to the top, their paths get closer together. Now, if they're clever beetles, they might try and figure out what's going on, and they could imagine that there's some mysterious force that's pulling them closer together. But for us, from our perspective, we can see there is no such force. All they're doing is following straight paths over a curved surface. Just as the beetles have no sense that the surface of the branch is curved, we completely fail to perceive the bizarre ways that gravity shapes the reality we live in. Einstein's problem was proving that he was right. After years more thought, he realized that there was a way. By looking far out into the solar system. Incredibly, here in the grounds of Hurstmonceau Castle is housed one of the original telescopes that were used to prove Einstein was correct. In 1915, when Einstein developed his general theory of relativity, it was just that. It was a theory. It had no proof. In fact, many people found it completely outlandish. But then just 4 years later, in 1919, this telescope, and allow me to geek out a bit here, and I'll give it its correct name. This is the 13-inch astrographic refractor. This telescope proved that Einstein was in fact right, that gravity does curve space itself. Since then, observation after observation have confirmed that matter curves space and slows down time. So the simple question of why things fall the way they do has led us deeper and deeper into the very nature of space and time itself. Gravitational science shows us how galaxies, stars, and planets form. By measuring gravity, we've discovered the existence of dark matter, that 80% of the mass of our universe is invisible, and we don't know what it's made of. And we've detected exotic objects with extreme gravity, like neutron stars, which have more mass than our sun, yet are only 20 kilometers across.